Assalamualaikum. Salam sejahtera to all. Hi, we meet again in part 2. So I will proceed with principle of superposition until standing wave resonance. Okay, so principle of superposition. The definition is if two or more traveling waves are moving through a medium, the resultant wave function at any point is the algebraic sum of the wave function of the individual wave, as you can see in the figure. Here, this one is represented by D1 and this one is represented by D2, and the sum is, this is the wave number 3, D3, and this is the sum of all three, so equal to T1 plus T2 plus T3 in terms of X and T. X is displacement, T is a time. Let's have a look at the reflection and transmission. A pulse or a wave undergoes various changes when the medium it travels changes, as you can see in part A and part B. It's depending on how rigid the support is. Two radically different reflection patterns can be observed. For example, in A, as you can see, N1, the support is rigidly fixed. So the reflected pulse will be inverted to the original due to the force exerted on the string by the support in the reaction to the force on the support due to the pulse on the string. Okay, inverted and reflect back to the origin due to the original force exerted. As you can see here, it's reflect back. Okay, in part A. If let's say the support is freely moving, okay, not rigid here, okay, then the reflected pulse will maintain the original shape. As you can see, this is the first one, then after and here, so it will continue in the original shape here, but moving in the reverse direction. So can you see the difference between these two, class? Alright, so it depends on the support, that is transmission. So different media, transmission through different media. As you can see in the figure, different media means when a pulse or wave travel from one medium to another medium, as you can see from the light section in part A to a heavy section, okay, different medium, part of the pulse will reflect and others undergoes transmission, as in figure B. Because of different media, so part of them will reflect and part of them will transmit, passing through the boundary and propagating in the new medium. So we can conclude that when a wave pulse travel from medium A to B, light section or heavy section, VA is greater than VB, then the pulse is inverted upon reflection. If let's say VA is less than VB, the pulse will not inverted upon reflection. For boundary condition, as you can see in the figure, the medium is different. One is light section, the second one is heavy section. When two medium occur, so half of them will reflect and half of them will transmit, as I mentioned earlier. When a wave encounter a denser medium, boundary condition means that end here, after it reach end here, it will transmit and it will reflect. Okay, so when a wave encounter a denser medium, the wave will be partly reflected and partly transmitted, the same as previous lecture. If the wave is speed, same as previous slide, if the wave speed is less in the denser medium, the wavelength will be shorter. Okay, please remember the hint here. For a 2 or 3D wave, For example, a water wave can be represented by wavefront. Wavefront, as you can see, this is a wavefront, which are curve or surface where all waves have the same pace. That is the mean by wavefront. A line drawn in the direction of the motion and perpendicular to the wavefront is called a ray. This is called as the line drawn in the direction of the motion, follow the motion, and perpendicular to the wavefront we call as a ray. So wavefront far from the source. When the wavefront is far from the source, this is, for example, this is our source. Okay, then it's become far away and have lost all their curvature and are nearly straight. As you can see, when the source are far away, when the wave are far away from the source, they become straight. For example, ocean wave, and we also call as plane wave, as in the figure B. For a reflection, still remember we have learned in chapter 1 the condition of reflection. For of a 2 or 3D plane with the angle that incoming or incident wave that makes with the reflecting surface is equal to the angle that met by the reflected wave, because it's happened in one medium. This law called the law of reflection, where the angle of incident theta I equal to the angle of reflection. As you can see here, the angle here is same to the reflection, is same to the reflected wave. Okay, this is a wavefront, this is a reflected wavefront, same. The angle of incident is the angle between the incident ray and perpendicular to the line to the reflecting surface, to the reflecting surface. The angle of reflection is the angle between the reflected ray and perpendicular line to the reflecting surface. Interference. Have you ever seen this kind of situation? Alright, what you can see from the figure? Okay, another example. Okay, as you can see in the figure here, there are crests, there are crests, and they are throw here. Whenever a crest go inside with a throw, okay, here on the horizontal line here, the water surface is flattened. Okay, as you can see, the flattened part is when a crest met with throw. Double crest here. Okay, as you can see, the white color, all the white color here. Okay, double crest here. What is when a crest coincident with crest? Okay, crest coincide with a crest, so that is why it will become double crest. Flatten region, okay, flatten region here, 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 and here. A crest coincide with a throw. Okay, understand, class? There are two types of interference, whether it double crest or it will flatten, or it will become a double crest. Okay, as I mentioned, there are two types of interference based on the figure previously. Okay, when two waves pass through the same region of space, they will interfere. Interference may be either constructive or destructive. Okay, A represent a destructive, B represent constructive. This one, when a crest met with a throw, so it will become destructive interference. This one, when a crest met with crest, so it will become double crest. The two wave is set in pace when the constructive